Good evening, everybody, and thank you for attending this session. I'm going to present a bit of historic background and how we got to have an Openchain compliant policy and best practice for open source compliance. And then the juicy part will be dealt with by my friend and colleague Alberto. My name is Carlo Piena. We both work at Array, which is a small outfit or a law firm in Milan dedicating to IT and more particularly to open source software. So without any further ado, how we got there. We started a project named Eclipse Oniro, and this project was an Eclipse Foundation project for an operating system. As I say, an old scenario operating system, targeting embedded IoT specification, and it's based on Yocto. So you know what this brings to. It was born as a twin project, as a Chinese-based project, like Open Harmony, started by Huawei and then got into Open Foundation, and it's evolving. But this is just how we started getting involved into this kind of compliance. The actors in the play, there is an Eclipse Foundation project named Oniro Compliance Toolchain, and we are Array, and our partner here, the technical partner of this initiative is Noi Tech Park, is a technological park north of Italy in Bolzano. It's a very nice place to be. It's a nice environment also to visit. If you ever want to go to the Alps, it's a place. Compliance is not one state. It's a process. You start from one place and hopefully arrive to a target which is full compliance. You're not there. You're never there. It's always a moving target. And it starts from a policy, so from drafting the blueprints and then design the process and then to make the process working. We have had a lot of challenges. Initially, we didn't actually knew how challenging the process was going to be. We learned a lot in the process. And thanks to many help from other people and from some help from the open source community as well, we have been quite successful. Never 100% successful, but yet. It started around 2020 when a guy started getting involved in this project. And they approached us to say, we have an operating system, an entire operating system for embedded software. It's going to be vendor neutral and entirely open source, 100% open source and 100% developed in the open. Wow. The main challenge is this big project, integrating 100 of components. All open source software, except for a very, 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 very small minority of components. It's entirely open source. And actually the proprietary components are at the hardware part, and it's in the world the highest source of complexity. And that's the interesting part. It started from the scratch to be an open source compliant project. We had open source compliance as one of the pillars since the beginning. It's not an afterthought. It was an essential component because we wanted to do the right thing from the beginning. And this is a very important concept. Although you may be, as an open source project, you have no many concern of because it never is going to get to challenge you. You're never going to be sued for copyright infringement, hopefully. there are exceptions, but you just publish open source, just publish source code. You don't distribute maybe artifacts. So you might be home free, but to be a viable project in the industry, you need to prepare something which doesn't create problem to your downstream, to your customers, to your the people implementing it. So you want to upstream to yourself most of the compliance work, and so that everything is already there. The legwork has been done, and this is the open source way. Solve problems upstream, if at all possible. And in order to make compliance easier to the implementers, we wanted to provide open source compliance artifact, things that can be used as evidence of the compliance made upstream to verify the job we have done. And as I say, in a transparent, cooperative way, so that everything we have done was in the open, and everything was verifiable. The data are there, the source code is there, the legal text is there, the policy is there, everything is open source. Why we're doing that? This is important to, it's a very little bit of legal stuff. Distribution is what in open source triggers obligations. And it's different distributing only the source code, original or modified version, and to distribute builds, things that interoperate together, because that copyleft there in the problems arise. So, and the basic idea is that you have to comply with the open source conditions, and this is because otherwise you are liable with copyright infringement, and you don't want that because it can be very painful. And so, in order to do that, there are some steps, some logic steps you have to complete. The first is that you have to know to ascertain what is in your software distribution, and this is called software composition analysis (SCA). This is just to collect information about what you're doing. So, and all these pieces come with licenses. Already identifying the licenses is a challenge, because there is no one way to announce what license your project is under. And sometimes this is more complex, because sometimes in project there are multiple licenses applying to the same project / repository / whatever. So this is already one very complex task. And once you have the licenses applying to your source code, you can calculate the sum of the obligations, and you can evaluate the risks of putting some components into your product and to combine with our product. And then you have also cybersecurity, you have other legislation that can be relevant as well, which go beyond the legal obligation, beyond the licenses. And that's not enough, because this is what you do initially, but things change over the time. So you have more components, you have more challenges, you have more features, you have more source code, and more licenses and more combinations. So this cannot be done once. It must be done all the time across the entire development time of the project. And this is this was our approach. You have to produce artifacts, things that can be consumed by your downstream to help them complying or demonstrating that someone upstream has done the homework, so you don't have to reinvent the wheel all over again. And this is a basic tenet for a viable supply chain. If you have because software it's a part of a supply chain. You have to rely on your sources, and the more evidence that your sources are reliable, the easier is your job demonstrated that you have done your homework. Okay, that was a very quick parenthesis on why we've done this. In 2020, we needed some standard to build our compliance, because we could invent the wheel, but this is not the way it's done. There is a standard. The standard is called Openchain. It's a Linux Foundation project. And again, it was conceived many years ago as a way to bring the same concept of good supply, reliable supply chain that exists in the general industry into the open source software world. And at the time, it was already being candidate to ISO standard. Now it's a full-fledged ISO standard. And at the rate, we have been partners since the beginning of Openchain. Openchain is a process, is a quality standard, if you want, to certify that you are doing open source the right way. You have compliance artifacts, you have things, documents, database, information that shows what you have done, that you have informed your staff, that you have educated people, you have processes in place, and you have done compliance work. And so your partners have an interface. They can know quite more easily. They can know what to expect and what they are going to receive as a compliance artifact. And the main compliance artifact is a software bill of material. Of course, you have heard of this. This is there are more than one standard, but the standard that we have decided to implement is SPDX, is a machine-readable software bill of material, which means that it can be processed. Remember, it's a very large project, many components, hundreds of licenses, thousands of packages. So, and the basic tenet is that in standard, you reuse the standards. Of course, it's not just about this bomb. It's about processes, it's about controls, it's about education, it's about a lot of things. And it grows and it is maintained over the time. And it can also be third-party certified. So you can self-proclaim, oh, I'm Openchain compliant, or you can have yourself certified by a third party. And with the last evolution, that's a natural evolution, which is once you know your software, you are better off to comply with security. And with CRA, the Cyber Resilience Act in Europe, this is already a giant step forward to be compliant, because at least you have, you can demonstrate what your software is composed of. So, but of course, having a policy, something written on paper, and maybe implemented into processes, assigning roles, having the initial education, blah, 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 is just the easiest part, because it only takes lawyers, so it must be easy. Sorry, pun intended. And software composition in this particular environment, Yocto-based, it's very hard because there is no package for starter. Many packages, but no package manager. So you don't have everything pre-cooked and offered to you. Of course, sometimes, many times, with package manager, you have wrong information, which is maybe even worse. But at least you have to do it from scratch. You cannot rely on third parties. You have to go and search for that. The information is not readily available. You have to scan. And sometimes you have to scan natural text. People saying things in a random way. Of course, you have a standard now, SPDX, but many projects don't use it. It's not compulsory. So they say, oh, this is GPL. Oh, just slap a license somewhere. Maybe it's contradictory. You cannot really rely. So we have scanners. And nowadays, the best scanner is an open source project called ScanCode, and then we use ScanCode to actually scan the text and to have information on what possibly the license applied to the package is. No assurances. You have to do a lot of work then. And there are a lot of false positives and a good chunk of false negatives. So things you can think that one project, it says, oh, this project is GPL, oh, this project is BSD. Maybe it is not. You have to review manually. Most of the time, there's a lot of human review, and it's very time-consuming and resource-consuming. And the expertise for doing that is not commonplace. It's not commodity. So we use a very nice project, although it's nice is a big word, but it's a project that works well. It's called Fossology. And that helps us in organizing this information and presenting and keeping and reusing this information for future activities, for future reviews. But when you have like 50,000 packages to be vetted by a human being, that will require years of work. And you cannot just wait years until sitting just waiting for lawyers to say, oh, it's okay. You want to be more time effective, and the open source way is to reuse what has been already done by others. And Debian is the most reliable source of information for many of the packages we're using. And so we use Debian in a very clever way. It was a joint effort, mental effort of many people in this room. And we needed to treat Debian as a friend that vouches for the quality, for the moral qualities of this alien software, namely third-party open source software that was entering our project. And Debian is a very extensive, very detailed, very accurate set of information about the packages that Debian uses, and it's a it's a lot. And also it's a machine readable, so we didn't need to scrape stuff or to do manually. So it was there, and it's good quality, and we reused that. And this is the last part of what we've done. So we have developed a tool chain that goes in pipelines. It's called generally aliens for friends. The alien is the third party, and friends is Debian. Or in reality, we can reuse other sources, but this is the one we have used to speed up the compliance work. And we have worked closely. We have, especially Alberto, has done a lot of work to implement this in a Yocto environment. And of course, we have integrated in these pipelines Fossology and scan code. We have already saw that. And we have a Debian matcher, so to say, this package is exactly the same package as scanned and released by Debian. So we have used everything is automated. There's a very little human interaction until the actual reading of the license. And it goes in. It's not in the building pipeline, but it uses a mirror. But it's done along with the building process, because anytime there is a new step in the software making, we are running again the process and can do the incremental work of the compliance. And last but not least, we have a dashboard that has an overview of how good are we doing in terms of getting to the result, which is 100% of the packages and verified and approved. So this is pretty much about it. This is the boring part of introducing the history. Now the juicy part, how it's done in practice and how these tools are working together. Thank you.
So I'm taking over here. I will not go into the details of this workflow because we don't have enough time, but just to give you an idea, this is the whole pipeline. That includes also human activity. So there is a decoupled part that runs in parallel with development activity. So we have... it doesn't. Sorry, it wasn't supposed to zoom.
It's Windows.
Windows. It doesn't work on Windows. Whatever. So here we have the...
Well,
no.
Quello basta.
Yeah.
Quello lì, quel triangolo.
No. So, sorry. Oh, okay. So here we have the build system specific part. So we collect the metadata from the Yocto builds, and we inject this metadata into the real toolchain, and we apply. We try to find a match in the Debian distribution. If we find an exact match or a close match, we try to compare the two code bases. I mean, the alien package or the package defined in Yocto and the package defined in Debian. If they are the same or mostly the same from a license and copyright perspective, so if the license and copyright notices didn't change from the version we find in Debian, from the version we find in Yocto, we try to apply as much as possible all the metadata that we have in Debian to the Yocto package. And in this way, we create SPDX file, so a SBOM generated from scan code and from Debian metadata, and we uploaded it into Fossology. If you're not familiar with Fossology, but basically is a tool that allows to run automated scanners and provides the auditor with an interface, a graphical interface, to review the results of the scanners and get rid of the false positives and to spot the false negatives. And but by inputting the SPDX generated from Debian, we are able to save a lot of work. So most of the matching packages will be will appear to the auditor already audited, maybe 90% of or all the files. And so we are able in this way to minimize the needed human audit activities. Then, of course, the human activity takes time, so we don't collect the metadata in real time. We do that in a subsequent pipeline, and then we harvest and collect all the data, and we show that into the dashboard. And so this is an example of a pipeline. So here we have the build part. So we build the whole build matrix of the project. There's a lot of stuff. Then we collect metadata. Then these are all the steps that you see in the chart before. And then we generate the software bill of material in SPDX format. And this is an example of the dashboard. In this case, the work is fully done. So this is a dashboard for the release of our project. And here you have the licenses funded the scanners and the licenses validated by the auditors or by Debian. And then you can have the details of each package, and also you have also some security related information. You can check the CVEs and check what CVEs have been patched in the Yocto recipes and other stuff. And so basically, this is for the tooling part. But another part we find it was very important was how we carry out the audit work. Because if we want to be trusted by the downstream, and if we want our work to be reused by the downstream, we need to do everything in a consistent, transparent way. So we drafted some audit guidelines in order to show the process and the criteria that are used by our auditors to review the code. And the final output is not just the software bill of material. Actually, we fixed some issues by removing offending components in the main project. And someone in this room remember what I'm talking about. So we also fixed a lot of issues in third-party components. So we open an issue upstream, and we talk to upstream developers. 80% of the time, we found them very collaborative. And finally, we got it fixed upstream. So it means there was, I don't know, a wrong license identifier or a wrong proprietary license notice that was removed, or was actually a proprietary component that wasn't supposed to be there, and so it has been stripped out from the upstream distribution and other things like that. In cases where we didn't manage to raise the issue upstream, or to solve the issue upstream, we reported the outstanding issues to downstream users in order to enable them to handle the risk, so that they decide to keep the component or not, or do something else. And so we put everything together in a final IP compliance note for the release. Moving forward, after the first release of the Linaro project, we tried to upstream the metadata collection logic directly to Yocto. So the first block of the flow chart I showed you before was about collecting metadata from Yocto, and you see the pipeline summary was the whole build matrix. To avoid to do all the build every time for compliance, we thought to upstream the same logic we are using by parsing the build directories into Yocto. So it was hard work because it needed to add an API to Bitbake, and but it took like 8 months. But in the end, we got it finally accepted, and now it is included in the current version of Yocto Bitbake. And so basically, there is an unpack tracer API that allows you to collect precise metadata about what sources are using in building the recipe. If you are familiar with Yocto, maybe you understand what I'm talking about. Some recipes can be very messy and put together a lot of stuff together. And currently, the SPDX bond generation by Yocto is kind of not imprecise, but it just takes the whole soup, but it doesn't tell exactly which file comes from which upstream package. So another thing we are trying to add is to be able to map binary files up to source files. So since only a very few source files are actually used to build the artifacts that end up in the firmware image, we need to be able to calculate the license of those artifacts based on the sources they are built from. And since sometimes those sources are subject to different licenses, we should be able to calculate by knowing exactly which are the source files that are being used. So we have developed a proof of concept, and now we are moving forward to get a fully working solution. And also, we dedicated to scale out to other projects. So we implemented the toolchain for another Eclipse Foundation project, which is Eclipse LEDA, still based on Yocto. It's an operating system for software-defined vehicle. And we also tried to implement the toolchain for Linaro TRS, just to show that it's feasible to apply the toolchain to other projects. For the future, we are willing first to integrate other tools. Open Source Review Toolkit, ORT, is a widely adopted tool, especially for the Java and JavaScript environments, and also for other environments. So it would be useful to integrate it, especially when we use in Yocto, I don't know, the NPN factor, so you can just use the tool. And the software W360, this project on another domain, is a tool to create an inventory of components used across one or more organizations in order to also to be able to put all of the information in one place and to be able to use that across different teams. Then another important goal would be to make Linux for Friends fully build system independent. So we born with within a Yocto project, but now since also Oniro project is moving to another build system, we will have to support that, and that build system is very similar to that one of Android AOSP. So in the future, Linux for Friends will probably support also AOSP. And we want to put all the information in a graph database in order to be able to calculate licenses of the binary artifacts. And this is something that is happening. It's something new. We want to integrate also the security compliance in the toolchain, but we will come to that later. So this is an example of the next generation dashboard that will show a graph database of all the components used to build a particular binary artifact. And just an example, you see a binary here that is built from different files, and some files are, have GPL2 or later, or GPL3 or later. Another file is GPL3 or later. And in this case, we should be able to calculate the license of this particular binary file that is not the same as the declared license of the package. So it is to solve this kind of problems that we want to use a graph database and to calculate the license of the binaries. So lessons learned down the way. So the first thing is reuse. So the logic steps are, first, automation is key. So we wouldn't be able to do anything in software composition analysis without automation, but human review is key too, especially in the Linux embedded space. So, as Carlos said before, human review is costly. So you may need hundreds of people to review a whole Linux distribution. This is not sustainable in the long run. So we should be used to reuse the work of others, and as well to enable others to reuse ours, because this is how the open source works. But reuse is not something that happens magically. You need to comply with some requirements we found down the way. So we must be sure, this is very important, that we are all reviewing the same thing. This is not trivial in embedded distribution because, as I said before, in a Yocto recipe or, I don't know, in a third-party component fork you put in an AOSP-based distribution, you can mix a lot of stuff together. So if you review a fork or a combined package coming from different sources, you cannot automatically apply the work of others. Others already been done on the same component because it's not exactly the same component, so it doesn't match. And on another side, we need to trust each other's work. So we need process transparency, and we need documented audit criteria. And we need to work with the upstream every time it is possible. So if we find a legal issue, the first thing that we must do is to try to solve it upstream. So that will solve that for us, for others, and if everybody is doing in this way, we will all benefit from this joint effort. The second lesson learned, continuous compliance. So as we said, human review requires substantial time. If we do that only before the release, it turns into a bottleneck. So it should be a continuous process flowing in parallel with the development process. So even if you use automated tools, you need also human review. So you need to take into account that you cannot expect to run a pipeline and to get the result. You need to run a pipeline, inject some metadata into the tool Fossology that auditors are using, and then collect the result of that work at a later point in time. And this seems easy to say, but it's much harder to implement. So the hard work we did was also in this field to design a process that can work, put it together, the automated part and the human part. And this is, yeah. And the third lessons we learn, compliance and security should flock together. So this is probably, you see this comics a million times, so I don't have to explain that. The problem is that this thing is happening too many times. And the last example we had, and it was mentioned yesterday with the XZ package, but there are many others. XV, yeah. So there were a lot of initiatives on both sides of the Atlantic. So the executive order by President Biden, and on the other side, the European Cyber Resilience Act. This means that in 3 years, about 3 years from now, that is the expected date where the CRA will actually apply to all software manufacturers who wants to market their products in Europe. In 3 years, first, all software, including open source software in some way, will need to be CRA compliant, to bear the CE mark. So there will be a CE mark for software, and more precisely for products with digital elements. This includes hardware plus software, software only, and also any software and related cloud services. So everything should be CRA compliant. Providing SBOM, or being able to provide SBOM, software bill of material, and doing due diligence for open source software will be mandatory. So it's not possible to go into the details now, but there have been a long discussion, and the final text of the regulation was amended to take into account the peculiarities of the open source community, but someone, in the end, will have to do due diligence on all open source components that are integrated in not only in a final product, but also in a component. So who's going to do that? Who's going to pay for that? And how do you handle that? Because if you put a component, a software component, into the market, even if it's not the end product, you are liable. And this assumes that you are able to do due diligence on open source software you are using. In 3 years, also the standards to comply with CRA will be defined by European standardization bodies, and the European Commission will issue guidance and delegated acts to implement CRA. So there is still a lot of implementation work to do, but I guess everybody is required to start now to be compliant in 3 years, because otherwise, because this will require quite a revolution in internal processes. As Carlo mentioned before, Openchain has evolved to cover this aspect. So there is a new Openchain standard, an ISO standards in December 2023, Openchain Security Assurance Specification. So basically, the idea is that in the future, you should not have an open source policy for license compliance and an open source policy for security or CRA compliance. They should go together, because the starting point is the software bill of material and the software composition analysis. So from that starting point, you can do both license compliance and Cyber Resilience Act compliance. And the fact is that you really need to put together tools, processes, and also training that are the key points of the Openchain standard in order to be able to comply with everything. So now, I guess, instead of a Q&A session, it's more, since this is a BOF session, I think Carlo would like to introduce the discussion.
Yeah. Since the crowd is not so big, we have a few points of discussion. Of course, we have not presented software. We have presented a system, and that enables to create compliance, and the software is a minimal part. Everything we have made, everything we have done is public, is open source, it can be used by anyone. But it's just part of the story. It's there's a process, there's people, there is expertise, there is knowledge about license, legal, technical, and also social. So these are the topics we are ready to perhaps discuss. Tools, of course, but also policies and processes. And we think that Linaro and other projects that are producing platforms are better suited to be the one taking the lead, because this is a great service to many. This can be done at many levels. It can be done at the last stage, but it requires time, it requires effort, and doing it at the very final stage before distribution is costly and it's duplicative. It's better and more efficient, and it heightens the value of the platform because it's technically viable, it's legally viable, it's more production ready. So this is why we have done it in Linaro, and is why we think it's a better place into Linaro for being a service and a better product to the clients, because it's a value added to the platform, because you spare money, you spare time, you spare a lot of resources, and of course there is no way to push liability, because liability is always in the final stage, but at least you have arguments, you have artifacts, you have process, you have evidence that you can present. You is the client, the one making products to the market, to show in case anything goes wrong, because shit happens and shit is going to happen. And VCRA is in heightened burden, because you need to self-assess and to make sure that everything is correct, that you have a process in place, that you have done your homework, you can produce a SBOM if required, then you can demonstrate that you can support in the long run up to 5 years your product. You can tap into insecurities, vulnerabilities, and in order to do that, you know where to find, you have to have the information. And this is a very consuming process. It's going to be a nightmare. And it's happening in 3 years. So it's something that if we do it together, if you do it once for many, that is going to be more efficient. Because it's not a matter of if and when. If we know it's going to happen, when it's going to happen in 3 years, and 3 years are just like this. So, any questions? Oh, Davide.
So, assuming we wanted to implement this at Linaro, right, and follow these steps and the processes and timing that you guys have, followed at Linaro, where would you start from? I guess an IP policy.
Yeah. This is another word. This word. Okay. Yes. As with building a house, you have to inspect the land, inspect the ground, and make a project. And the IP policy is like the blueprints. And then you have to assess how much it will cost, what kind of house you want. Of course, you have to comply with regulations, zoning, heights, distances, pipes.
And once you have the IP policy, I guess you're going to have to train the entire engineering team to follow it, at least the high level.
Yeah, the policy is part of an Openchain. Openchain has multiple factors and multiple pillars, they call it. Education. Why are we doing that? What's behind not just what you have to do, but why you have to do that? This is an important part. We do a consultancy. We could do education on IP, copyright, and all the technical stuff as well, but mainly legal, just to have a grasp of the legal implication and the risks that you are running. Of course, security, everybody should understand risk, but there are also a legal risk, a legal obligation to be compliant. So this is another part. And then, of course, there's the technical stuff and implementing the pipeline, scanning and doing all the work. You have to see. Of course, doing it the first time is time consuming, but it's an incremental. So the first time is hard. The next times is easier. And it's when you're up and running. That's the beauty, because you see the results of an investment. I think it's a 6 months to 1 year project.
Question.
Yeah.
So you talked about the unpacked tracer API for Yocto. Does it mean it exists? I mean, is that applicable only to Yocto? How about other OSs? How does it work?
The thing is that you need to, if you have a Debian package, you have the original upstream source, then you have the Debian directory where you find the patches and all the metadata, and everything is very clear. You need to get mostly the same information from a build system. So that part is very build system dependent. So for Yocto, we design a set of scripts to extract metadata from the builds. We upstream the logic into BigBake, so you need an extra layer also to consume that API and to get the metadata. If you have another build system, I don't know, AOSP, you need to design another way to get the same metadata from that other build system. Once you get those metadata, then you can run the whole toolchain, because the toolchain has been designed to be agnostic.
Agnostic of any OS, right?
Yeah. But the thing is that you need to get the same metadata.
Okay.
Yeah.
So the unpacked tracer API helps you get that in the same metadata in the format you need for the scripts to run.
Yeah, basically the metadata is which are the origin of so your provenance of each source package. If you have multiple source packages combined into one repository or into one recipe, you need to understand also how those sources are combined together. And basically it's, also because if you want to do, I don't know, CVE checks, right. Yeah, that's not possible if you don't know.
Yeah, very quick. We speak of Yocto because Yocto is probably the environment that brings the most problems, because it's very powerful and it's very complex, and it can take in any rubbish that you can consider. So you don't really know where to go. I compare it to driving a motorbike or driving a MotoGP. So the technique is basically the same, but the amount of things you have to do to drive it effectively is completely different. So it's when you're done with Yocto, the rest gets easier. So we have done a scan for Linaro already for a proof of concept, and of course, it has different elements, but it's comparatively easier because it's Question.
Continuing on the same vein, could you express that metadata that you need in an SPDX file so that all projects, build systems could generate that type of SPDX file and you would have the metadata?
Yeah, the thing is that SPDX is basically, I'm simplifying a bit, but basically you need to know the provenance of an upstream package. You need to know the checksums of each source file. So you don't just need the package. You need also to have the list of the files that are actually used, and in a Yocto recipe, you can have multiple sources. You can have single files imported from an upstream source that is probably some fat patches.
So in Yocto now, the SBOM contains per recipe just one description. But if you would change that SBOM to have, instead of just one, I'm not sure what the element is called, but one object per recipe, you would have one object per source of the recipe.
Yes.
So with a separate checksum for the main tarball, each patch, each extra configuration file, etc., etc. Wouldn't that already...
Sorry?
I mean, wouldn't that solve the problem? I mean, wouldn't that give you all the information?
But that's the work we were done with the Unpacked Tracer API. So because currently, before we talked to Yocto people, they were producing an SPDX file describing the recipe, and the upstream provenance, the download location is in the SPDX terms, was just the first entry of, that was not acceptable. So now they changed, they put all the source URIs in a separate SPDX object, and then you have the whole bunch of sources, but the provenance is not asserted. So it's a lack of compromise, because if you lack an API to trace how sources are combined together, that was the only possible solution that was implemented because we requested that, at least to avoid uncertainty, to have wrong information.
To give you an idea of the level of granularity that we wanted, our goal in the result is that we track any single source file down to the least patch. So if there are the same packages using two different places with different patches, we need to track them down with a SHA-1, and so that we can demonstrate what sources go into the build. So we can say, oh, this is patched, this is not patched. This is vulnerable, this is not vulnerable. This is patched, this is not patched. This is kind of, and only by tracing the flow this is possible. Otherwise, it's just heuristic. It can be good enough for compliance, perhaps, but not for security. So in order to meet the requirement of CRA, you need these sort of things. And with Yocto, we have done this patching, and that works.
Yeah. If I may ask another question still. Okay.
Yeah, because we have all the night. If you can stay longer.
Yeah. Okay.
See that.
So Yocto produces an SBOM, but you're basically saying it's useless, right?
It was. I'm not saying it's useful.
It's not good.
It's useless. I mean, I make an example. It's not an actual security or license compliance issue, but the bzip2 recipe, there is a file, source.ri entry, that puts a make file within the folder of the upstream sources. If you look at the SPDX produced by Yocto, it seems that file comes from the upstream package, while it has been added downstream. And this is not visible from the SPDX file. You need to inspect the recipe, understand how the file is imported into the project, into the work tier, and you cannot be expected to do that by hand, recipe by recipe. So we wanted to have an SPDX report that actually reflects how the files are combined together. So in that case, you need to say this file is not coming from the bzip package. It's a patch coming from the layer. And so you got the Git repo of the layer and the path of so you know where that file come from. And that's basically, or if you have very complex recipe, I don't know, Python 3 cryptography has a bunch of dependencies of different types all together in the same recipe. You cannot just say it's all one source. It's not one source. So in NPM shrink wrap recipes, the same problem. So basically, we are trying to improve the current situation but the only thing that you need to trace the unpack process until it happens to get those information. Otherwise, it's too difficult.
We mentioned NPM. Don't get me wrong. It's not that because there's a package manager, you're home free and you don't know. Yeah, there's a lot of extra work you have to do in that space also. You are starting from a different point. But a false sense of security is sometimes worse than
that was
itself.
actually what I was getting at. Wouldn't it be better to not pretend that? I mean, I'm not a Yocto developer. I do make build root, which is kind of similar to Yocto, and so we are considering making an SPDX file, but it would be of the same quality as the Yocto one, so a bit approximate. Does it even make sense to do that? Because in the end, you need to go a lot further than that anyway.
Well, it's difficult to tell in a vacuum. You need to see to look at the circumstances and the practicalities. But sometimes this is all you see. Of course, you need to know what you get. If it's you cannot if it's just a SPDX made of because it's just a descriptive, but it's okay. But you must be clear that you cannot find a level of reliability in the information that you should expect for full compliance. So it's something, and you can take it as it is. It's not. So what we wanted in the Yocto space, conversely, was something which we could safely say we have done a lot of work and we know what was there, and this is the end result of a compliance. So the object looks pretty much the same, but the requirements are totally different. So we can take one more question if there is another. Otherwise, we are past our time. Yeah. Okay, thank you very much. You're a great audience. Thank you very much.